All right, so we're working on our elastic collisions here. So for this, guys, what you're going to be doing is you go to the physics classroom simulation for collisions. Remember what we just kind of talked about, that the momentum before the things collide, right? So the momentum before is going to equal the momentum after the collision. So they have, in the collision one, they tell you what they want. They said set the initial blue car velocity to 0, set the masses to different values, run the simulation, and record mass and velocity values. Okay, so they want the blue car initially at rest. So I have to click on the slider, make it at 0. And now if it's over here, you can click on it and drag it, make it a little closer. Now the picture shows, the diagram shows an arrow going to the right, which means it needs to be positive velocity. So we just can't have a negative number. Okay, so it's got to be greater than 0. So obviously it can be 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 10. I'm going to pick 8. You guys will not pick 8. You will pick a different number. All right, so but this is going to be the example of how you do it. Okay, so definitely pay attention. It also wants the mass to different values. All right, so my suggestion would be make the red a greater mass than the blue. So if I have the mass of the blue as 1, I can make the mass of the red 2 or 3. If I make this as a 2, I can only make this guy a 3. All right, so that's my suggestion. Now I'm doing this. You guys can do 2 and 1. You can do 3 and 1. You can do 3 and 2. Whatever. This is what I'm using. And 8 meters per second. So what I would need to do then is I'm going to write some of this information down. The mass of the red car. All right, I made it 3. The mass of the blue car, I made it 1. You guys will have differing numbers. I made the mass of the red car a positive 8, and they told us that the blue car has to have a velocity of 0, so this thing's velocity is 0. Now, the after collision stuff, we don't know. We have to wait until, all right, we run the simulation. So if you've already run something and then you can't change velocities, make sure you guys hit the reset, and we should be on elastic collisions, not inelastic or explosion. So right now, this is what I'm dealing with right here. I wrote down my starting velocity. Velocity of the blue should be at rest because that's what they tell us in the problem. And I have my masses. So what I can do first, before I actually run the simulation, is I can then basically take my numbers and I can put them in. For the red cart, what do I have? I have a mass of 3. And now this is before collision. This is the momentum before. This is the momentum, which is lowercase p, after. So what was my velocity of the red car before they collide?
I didn't get one of the papers.
Right there. So the velocity is 8 for me. You guys will have a different velocity. It can be 1 through 10, just not 8. All right, and I do this, and I get a value here of 24 kilogram times meters per second, because that is the unit for momentum. And then the blue cart. Well, what is the mass of the blue cart? Right here I have it listed as 1. kilogram. Cool. And what about its velocity? Yeah, I have it set to 0. Beautiful. Now, what does this come out to be? Super simple. Minus 0 kilogram meters per second. Now, if I add these straight down, 24 and 0, if I add those together, I get a total value of 24 kilogram times meters per second. Ba-bam. And then I have to run my simulation. So when I run the simulation, I'm going to go back to this. I just hit start, wait for them to collide, and I'm going to hit pause. Okay. The mass of the red is now what?
4.
And the blue?
Is 12.
So I would put 4 and I would put 12.
Happens if yours comes out to a negative number. Is that good?
Huh?
Mine comes out to a negative number. Like the red car is negative 7.2. Is that okay?
It shouldn't be negative. It shouldn't be. If your number comes out to be a decimal here, that is okay. Just note that they round their decimals, right? They only give you one decimal.
Yeah.
So if it's 0.3, if it's like a 0.3 or 0.7, the 0.3 was supposed to be like 0.33 repeating, which is basically like 1/3, right? So if you do 0.33 repeating multiplied by 3, it comes out to be a 1. All right, so just keep that in mind, right? A 0.66 whatever repeating, multiply that out by whatever, all right, 2/3. You're going to wind up, if your decimal doesn't match, just know that that's just a rounding thing, okay? That is just a rounding thing. And when you do the adding at the end, if it comes off to be one decimal off, that is the only reason why. So let me finish the example, and that should make sense. So I have my 4 and 12 after the collision. Guess what? The mass of the red car didn't change, so that's still a 3. The mass of my blue car didn't change, so that's still a 1. But the velocity's after. For my red car, it's a 4. And for the blue car, I have a 12. 3 times 4 is 12. And 1 times 12 is 12. Same idea, we're going to add the 2 up. What's 12 plus 12? 24. Okay, so cool. Let me ask you this. What was my total momentum of the red and blue car before they collided? 24. What is the momentum of the red and blue car after they collide? Did that change? No. So that means, all right, momentum was conserved. Momentum wasn't changed on us. All right. Now, one may have more, like the one car may have more momentum than the other, and right. So this one now has less than what it started with. This one has more than what it started with. But at the end of the day, they're both going to have the same value. Now, what we do here is you do the momentum after, so P after, which I have as 12, minus the momentum before. Momentum before I have as 24. What is 12 minus 24? That comes out to be a negative 12 kilogram meters per second. In the next situation, the after is 12, and the before was 0. 12 minus 0 is just 12, a positive 12. And then for this, all right, the total change in momentum, you add the two. All right, so you will, here you're going to, all right, before, so negative 12 plus 12 equals 0. So the net change in momentum of this whole thing is 0. Even though the red cart basically lost 12 kilogram meters per second worth of momentum, the blue cart gained that. So the overall change in velocity or change in momentum of the whole thing is 0. All right, and that, again, that also should make sense because we have 24 total before and 24 total after. Okay, so you guys will complete this table, but you're going to use your own values. And then the only other thing that I want to talk or mention here is see the arrows. So the velocities should both be positive. Don't make one of them negative. Make sure that the blue cart has a velocity less than the red so that the red can catch up. So, for example, if this was 5, see how it catches up? Boop, and you get a change here. You don't want to make this like 7 and have the blue car all the way out here because, well, I guess you technically could, it just doesn't look as cool. Get him. Oh, so close. All right, you can change it. You don't have to have this. You can have this lower, but the blue has to be lower than the other. All right, and then you're basically going to do the same setup. So I'll leave the example up on the projector for you guys. And again, blue cart, it has to be less. And make sure that the blue cart has a smaller mass. So again, the red cart needs to have a bigger mass, right? So looking here, I can't change it. If I hit the reset button, I can. If I do something like this, okay, that wound up working. So for here, guys, that is what you're going to need to do, all right? If you're sitting next to someone, you guys want to like kind of work it out, talk it out together, you can, all right? Or you guys can do it on your own. That's perfectly fine, all right?